So good afternoon, everybody. Welcome to week 4. Remember, under week 4, we are going to look at unit 8 and unit 9. Before I proceed, I really want to appreciate some people that are trying to help us put other students through. If I'm permitted to mention name, I can see Kefi. Kefi, can we see you? Kefi, let's see you.
A moment, please.
Okay, maybe I'll go ahead. I'll still appreciate you towards the end. But let's look at what we have in unit 4. Kristen, I still remember you, but if you finish what we have under unit 4, I will still have time. Kristen, you talk to us, okay? But okay, before that, let's go ahead with unit 8 and unit 9. I believe by now you have visited our course page and look at what we have under unit 8 and unit 9. So I just want us to go through very fast. And if you have any question under those units, I will attend to them. If you can see my slide, you just use the reaction board because I've started teaching. Just indicate by using the reaction board because I've started. Remember, the first step is the and today we are going to cover unit 8 and unit 9 under week 4. So under unit 8, we have the fractals, skewness, and kurtosis. Under unit 9, you have measure of dispersion. We are going to look at the units one after the other. Looking at the fractals, what comes into your mind immediately you have the word fractals. The definition is on page 95 of your course guide. Now the fractals is a cutoff point for a certain fraction of a sample. And under fractals, we have quartiles, deciles, and percentiles. So the quartiles are divided into 4 equal parts. The deciles divides data into 10 equal parts, while the percentiles divides data into 100 equal parts. We go ahead to define the quartiles, saying that it measures the spread of values above and below the mean by dividing the distribution into 4 equal groups. And for the deciles, it measures the same as the quartiles, but it divides the distribution into 10 equal parts. For the percentiles, it is a way of expressing where an observation falls in a range of other observations. And in the case of the percentiles, it's divided into 100 equal parts. If you look at the next slide, you have the quartiles. That's the formula to calculate the lower quartiles and the formula to calculate the upper quartiles. Remember, I told you that you stick to your course guide. So because of that, I'm going to use the explanation in your course guide to illustrate how you can put the quartiles. Let's look at what we have in our course guide on page 95. The quartiles formula is equal to Li, which means the lower class boundary of the class containing the quartile. The W is equal to the class width of the class interval. The Fi is equal to the frequency of the class containing the quartile, while J is the total frequency multiplied by the percentage value of the quartile minus the sum of all class frequencies up to, but not including the quartile class. We use illustration to explain that. That's why I said all of you should come with your calculators, okay? Look at the table that we have. I have my class intervals, 3 to 7, 8 to 12, 13 to 17, 18 to 22, 23 to 27, and 28 to 32. You have that on your course guide. So I want us to use the table to compute the lower quartiles and the upper quartiles. So with the formula I just showed you, looking at the table, I want us to have the values of LOI. I want you to give me the values for LOI, W, Fi, and J. Let's be fast about that. LOI, W, Fi, and J. So that we'll be able to compute using the table the lower and the upper quartiles. Let's do that fast. Who can give us the value before we go ahead? Remember, we want to compute the lower quartiles and the upper quartile. Our class needs to be more of interactive class. So when we got to a point we need to compute, you can indicate by using the reaction icon, and I'll mute you and you interact. Who have any of the values? Okay, let me go ahead and share, maybe give you an example how you do the upper. Let me take one of them. Let me solve for the lower quartiles as you solve for the upper quartiles, please. For the lower quartiles, using the value, this is what you have. Look at what I have on my slide. I have for the lower quartile or first quartile, the position of 25 over 100 times 58 to give you the 12.5 item. It's at that particular point that you can trace the class interval. We look at the lower class boundary of that class interval. That will give you 7.5. The frequency of the class interval will be what? 8. Our width will be 12.5. That's the lower class boundary of that class interval. The upper class interval minus the lower class interval, which will give you 5. You have our J, which is the position of the class interval minus 6. The frequency you have calculated up to that class interval without including the frequency of that particular class interval, which will give you 6.5. Before finally you evaluate using the formula to get 10.75. I'll pause a little to hear the reactions of anybody that didn't get the solution. Look at the slide very well so that I can ask me questions based on the slide. If there is no question, I assume that it's clear and I move to the next one. Look at the slide very well. Is there any confusion how you get the figures? Is there any problem you don't understand? Is there any question you have on the slide? I use this table to generate that. Remember, the first thing you do is to, okay, Kristen, let's hear you.
Ma, please, can you shed more light from the top, please, because I don't really understand.
Okay. Have you bothered to look at your course page? You saw the last instructional video I posted. Did you watch it? Okay, good. Now, if you want to compute lower quartiles and upper quartiles, remember I told you, you are going to use this formula for the quartiles. The difference between the quartiles, deciles, and percentiles is that the quartiles is divided into 4, the other decile divided into 10, and the percentile into 100 places. It's just, this is the formula you use in your course guide. But generally, if you go online, you can see this other formula, which you just replace the 4 that you have there with the 10. Replace 4 with 10 if you are computing decile, and replace that 4 with 100 if you are computing percentile. But I promise to stick to your course guide. That's why I'm using the formula that is on course guide to explain how you can get your quartiles. It's still correct, and it's even simpler if you can follow. Look at the definitions under that formula. I said LO1, you have lower class boundary of that class containing the quartiles. Remember I told you that I'm going to handle for the lower quartiles. Now, going for that lower quartiles, is divided into 25% is for the lower, 50% is for the medium, and you have 75%, which is seen as the what? Upper quartile. So I told you that I'm going to handle the lower quartile, which is 25%. The first thing I'm going to do is divide, look at the table that I'm going to extract my lower quartile. Divide 25%, that is 25 over 100, times the total frequency. Look at my arrow, look at what you're going to add. You add everything. Everything here will give you what? 50. Try and see if you're on the same page. Do the calculation by yourself. You are going to have 50. This is what? Frequency. Remember in the previous class, I taught you how to compute the cumulative frequency. Cumulative frequency means in the first column, you are going to have 6. The next one will be 6 plus 8. It will give you the next value. The next one will be 8 plus 16 until you have the last point, which will give you what? 50. So before I proceed, compute the cumulative frequency for me, but it will be very fast because I need other solutions that I want to give you that can aid you to understand unit 8 and 9 very well. So give me the cumulative frequency, please. Be very fast. The first one is 6. What's the next value? Another American assistant, let's be fast. What's the next value? 8. Cumulative frequency. You are calling frequency. Give me the cumulative frequency. I just gave you how to. The first one is 6. 14. The next one is what? 14. Good. The next 14. One is what?
26.
Take it easy. No. Take it easy. That's wrong. I said the first one is 6. The next value will be 6 plus 8, giving you 14. Okay?
14.
The next one is what? 8 plus 16.
That's 30.
Good. Plus 10.
40.
Plus 7.
47.
And the last one?
50.
Complete. That's very correct. That's how you get your cumulative frequency. The cumulative frequency will help you to know where the 12th item or the lower class item belongs. So with that, our 12.5, remember I told you that the first thing you're going to do when you're looking for the lower quartile is what? 25 over 100 times 50. 50 is the total frequency. That will give you what? What's the value?
12.5.
Thank you very much. So I hope you have your cumulative frequency written down. What is the range that you can get your 12.5?
Between
let's not waste more time. Between 8 to 12.
Between 6 and 8.
Talk about the class interval.
Okay, 8 and 12. Sorry.
8 and 12. So my concentration will just be between 8 to 12. And my frequency is what? 8. So now let's get the value for the parameter. Mute yourself, please. Mute yourself so that you'll be able to grab what I'm talking about. Please. Mute yourself if you don't have the floor. Now I'm concentrating on the class interval 8 to 12 because that's where I have what? My 12.5. Okay? So now let's fill the parameters. I said the lower L, for the lower class, for the lower quartiles, I'm making use of 7.5. Do you know where I generated that? The class interval of that particular class I'm interested. What's the lower class interval for between 8 to 12? Can anybody tell us?
7.5.
Thank you. And the upper class is what?
12.5.
Thank you very much. So with that, you are good to go. The lower class interval of that particular class is what? 7.5. And the frequency of that class is 8. You can see the frequency 8. For you to get your width, you are subtracting the upper class interval minus the lower class interval, which somebody just gave me now, making it 5. And remember, your 12.5 is what you generated as the ith item. And the instruction for J says that you subtract the frequency, you minus the sum of all class frequencies up to, but not including the quartile class. Remember, our quartile class is what? 8 to 12. So we are summing only 6. We are not going to add 8. That's why we are subtracting 12.5 minus 6, giving us 6.5. If you evaluate all the parameters you have got and put them into that equation, what you are going to have is what? L1 plus 6.5, which you have computed from here, times your class width equal to that statistics. So now, please, with that explanation, who can give us first the upper quartile? Somebody should try the lower quartile following the steps I gave you. Remember, we don't have much time and I need to explain others like this. So follow these 10 steps, compute for the upper quartile. What's the first step? Who can attempt? What's the first step when you want to compute the upper quartile? What is the first step? Anybody? Indicate by raising your hand. If you have finished filling the parameters before evaluating, let me know. Is there anybody that can help us with that? The upper quartile, following the steps I've given you on how to calculate the lower quartile. Anybody? You know, I gave you the lower quartile and upper quartile to compute. I've illustrated how you can compute the lower quartile. Can anybody attempt following that step to compute the upper quartile? I'm waiting. Well, as we wait for the solution for that one, even though I have that on the slide, but I want you to make attempt to look at the decile. We look at the decile, or how you can compute the decile. Remember, I showed you how you can compute the upper and lower quartile. If you follow that pattern I showed you for the lower quartile, you can compute the upper quartile. We just want to look at, if you're not dividing by 4, you are dividing by 10. That is the decile. How do you compute that? Now, remember, I just finished lower quartile. Now, I don't want to go to lower quartile and upper quartile. I want to use a definite position. I want to, when I ask you to compute for second decile, third decile, fourth decile, 94th decile, you can comfortably do that. It must not be only first and second quartile. So this example that will help us go through that. I said using the frequency table, compute the second and the seventh decile for the distribution. So in the same way, I'm going to illustrate using 1, and you follow the same pattern and compute the other one. So you're going to pay attention on how we are going to do that. Remember, I told you that it's the same formula. What you just need to do instead of dividing by 4, you're going to divide by 10. So let's look at the first one. How do we compute the second decile from this table? We follow the same rule. The example is on your course page. I extracted that from your course page. Example 8.2. Yes, example 8.2. What we have for second decile, notice here the position given to you, that's what you put and divide by 10 times the total number of frequency to give you the item, the position of the second decile. So in this particular case, the position of the second decile is the 24th item. Remember, if you're given 7, you just replace these 2 with 7 over 10, you times by 120. Then the next thing you need to do is to find these parameters from the table, following the steps I've given you. The lower class interval for the 27th position we are looking for is what? 40. That's where we got our 40. The frequency is what? 27. It's here as 27. Okay. The width is 20. How do you derive that? 60 minus 40, 40 minus 20. They are supposed to be constant, so they are the same thing, 80 minus 60. Okay. Then you get your J. Remember, you're looking for the second position, and you have computed it to be 24. So 24 minus 11 will give you 13. Remember, it's 24 minus the cumulative, excluding the class that you are interested. If you are able to get that, just substitute in the formula. You are going to have 49.63. Follow the same pattern as I said. For the next one, you are going to compute 7. You remember the last one, you have this position to be 2 because we are computing what? The second item. Here we are computing the 7th item and we are replacing with 7. Other procedures, everything will follow suit. When you input in your formula and substitute, you are going to have 90.7. With that, I'll move to Unit 8, where we talk about skewness. We look at the skewness and symmetric of a distribution. Look at the direction of the skewness, the degree of the skewness, and averages in a skewed distribution. How do we achieve that? Under skewness, we just try to reveal certain features. Skewness tries to reveal certain features about the distribution with the slope on the either side of the peak. So you are expected to know whether the distribution is positively or negatively skewed or symmetric, depending on the direction of the skewness. So in skewness, you are expected to know the formula. SK is equal to 3 into mean minus median and standard deviation. So for you to compute the skewness of a distribution, you first of all calculate the mean, calculate the median and the standard deviation. Just the 3, you put in the formula we have on the slide to know whether the distribution is positively skewed And you know that by when you evaluate this formula, if your statistic is positive, you know that the distribution is what? Positively skewed. If the value you got from this formula after evaluation is negative, you know that is what? Your distribution is what? Negatively skewed. And when the value is 0, that means there is symmetric distribution. And the idea of that is just to measure the symmetric of the distribution. If the value is 0, you know that it's a symmetric distribution. If the value is not 0, you know that is either positively scaled or negatively scaled. And you can get that from the value you got after evaluating your skewness formula. So with that, we look at kurtosis. What is kurtosis used for? Kurtosis is used to determine the heaviness of the distribution terms. Kurtosis is used to determine the heaviness of the distribution terms. And we have 3 of them. After plotting your distribution, if you have the first curve, you call it what? Mesokurtic curve. You just conclude that your distribution has a mesokurtic curve. If the distribution after plotting have this particular shape, we call it what? Lithocurtic curve. And the final one is what? Lithocurtic curve. So it's the 3 of them that we have that can determine the heaviness of the distribution term. That's the sole aim for our kurtosis in a distribution. Okay. So we expect at the end of Unit 8, you should be able to compute the different types of fractals in a distribution, describe different types of skewnesses, compute the degree of skewness in a distribution, locate the relative positions of mode, median, mean in a distribution, and finally, explain measures of kurtosis of a distribution. So there is activity that comes along after you have exhausted Unit 8 on your own. You are expected with the idea of histogram drawn from the task, show the type of skewness of the distribution, okay? Whether the distribution is positive or negative, or whether the value is what? 0, showing that is what? Symmetric. You're also expected from the table to compute the lower and the upper quartile, compute the 47 and the 72 percentile, compute the 9th and the 5th decile. You just need to follow the pattern I showed you how to compute the decile. Where we have our 2 and 7, you just have your what? Your 9 and 5. And with that, you have no issue in the computation. So I would like to look at Unit 9, where you have the measure of dispersion. We are going to cover the range, the mean deviation, quartile deviation, standard deviation, and finally the coefficients of variation. Let me stop sharing and know whether anybody have tried to attempt our first quartile, or if I have any question there before I move to Unit 9. Mary, unmute yourself. Let's hear you.
Good afternoon, ma'am.
Good afternoon.
Ma, I didn't understand the decide, and I feel like the time is short and we can't understand. I don't know if any other person